1.4 vectors in 3D space. When we draw a 3D graphs, we have such a thing. So we have a Z direction, we have X direction, and Y direction. So when we talk about the vector in 3D space, we talk about X component, Y component, and Z component. Let's just look at this example. Let's say you want to draw -3, 2, 1. This is your axis, right? This is the x-axis. If you continue it to the back, would be negative part of the x-axis. And here, if you continue this one, this is gonna be negative the y. So basically, this is your y-axis, positive. Here is x positive, and here is z positive, and z negative is down. So -3 means your x is -3. So you just go 3 units on the x-axis. So this is -3. And your y is 2. Here is your 2. So you make a parallel line. Make it in another color. You make a line parallel to the x-axis and parallel into the y-axis, right? And then you go -1, a 1 unit down, right? On x-axis, let's say this is -1. So then you have to draw that parallel into the y-axis, right? And there, I just erase that. This. So here is one is -3. -3 is there. This is that point, and this, sorry, this is 2, right? How about that? There is that. Here is -3 that you make a parallel with the y-axis. Here is 1, you make, here is 2, y component is 2. You make it parallel with the x-axis, and let's say here is -1 component. So therefore, that will be the point, which is -3, 2, and 1, and negative. Okay, to Cartesian vector, again, we have x and y and z component means you move in the x direction, y direction, and z direction. We have a unit vector in 3D. I is along the x-axis, the unit vector 1, 0, 0. J is the y on y-axis, we have 0, 1, 0. K is 0, 0, 1. All unit vectors have the magnitude of the 1. Of course, magnitude of the vector in 3D space is x component power 2 plus y component power 2 plus z component power 2, the square root of that. Scalar multiplying in 3D, the same thing that we do for 2D, we can do for 3D. You multiply a vector by a constant, you multiply each component by that constant. So KU1, KU2, KU3. If the U and V is given and you want to add these two vectors, add the x components, add the y components, and add the z components, and that would be the resultant for the addition of these two vectors. And if you want to subtract these two vectors, just minus the x component, u1 minus v1, u2 minus v2, u3 minus v3, as you see the vector subtraction here. Vector between 2 points. Again, when you have p1, p2, you have to do p2 minus p1 if you want to write the vector p1, p2, p2 minus p1. So it's going to be x2 minus x1, for x component y2 minus y1, and for z component z2 minus z1. And the magnitude of this vector is the total x component power 2 plus total y component power 2 and the total z component power 2. That would be the magnitude of this p1, p2 vector. So dot product would be the same thing. If you want to do dot product, x value multiplied by x value, u1 multiplied by v1, what plus y value multiplied by y value, u2 multiplied by v2 plus z value multiplied by z value, u3 multiplied by v3. Again, if you have a perpendicular vector orthogonal, the dotted product of these two vectors will be 0. So question number 1 you can do, question number 2a, b and c, question number 3a, question number 4 you can do, question number 5, question number 6, question number 7, a, b, c, question number 8, question number 10, a, b, question number 11, a. Yeah, that's it.